Hi class, hope everyone's doing well. I just wanted to quickly just go over some of the topics that we are been learning, that you've been learning in week 3. Okay, so one of the major topics is function prototypes. In function prototypes, you've been using actually, when you're creating your classes in a header file, you declare your function prototype, right? You declare your function, then you implement or define it within the CPP file, right? So some of you did this and I demonstrated this in an example in a prior module, prior video as well. So I just want to go an example of actually how to use prototypes. So you can see here is an example of a simple program that adds two numbers, right? And it uses this function add. So you can see the function here, and we use the function right here. So we ask the user to enter two numbers, and we call the function add. We pass in num1, num2, and we display the result. Okay, so you notice that this is all okay because we're declaring and defining the function before we use it, right? So let's actually run this and just see what happens. Okay, so here's the program. We can type a number, say 3, 5, result is 8. Okay, good, it works. All right, so that's good. So now what if we actually took this and moved it to the bottom? Okay, so now we're defining it under the main function. Okay, and we're going to run it again. Okay, you'll see that there is actually a compile time error, right? So there's an error because it's trying to use this add function that we actually had never defined, because you have to define it before using it, and we're defining it after, right? So how do we fix this? So the way to fix this is we can use what's called the function prototype. Okay, so I'm going to close this. And basically what we do is we can just declare the function before we actually define it. So we can declare by creating the function prototype here. And we basically can pass in the same, it's the same return type, same parameters, except not implemented, right? We don't actually define what it does until down here. And notice that the how we declare it has to match, right? The parameters, the name, and the return type have to match the prototype, okay? So let's run it and see if we get an error. Okay, there you go. So it does allow us to run the program, right? So we can type in two numbers and it prints the sum. Okay, so that's the idea of function prototypes, right? We can actually declare the function prior to defining it. Okay, but we have to always make sure that we do define it somewhere in the program, in the file. So we can define it down here as well. We can define it somewhere else, right? So as we did with the classes in a different file, we can define it. But the idea is that it must be defined somewhere, and if it is defined in another file, that we include that file. Include the file that contains the prototype. Okay, so that's the idea. Okay, so additionally in the prototype, you don't actually have to specify the name of the variable, right? You can do something like this, just specify the type of the variable, of the parameters, and it will still work. Okay, so as you see here, we can say 3, 4, we get 7. Okay, good. So another thing I just want to show you is the idea of kind of giving default values for functions. So you can also do this. AB default will say 1 equals, and default value is 3. So just for demonstration purposes, we'll show that we can create default values for the parameters so that if no value is passed in, it could still operate. Okay, so say we went here and we didn't pass in a second argument. We just passed in one argument. So by default, it's going to set the second argument to 1. So when we run this, okay, we're going to pass in our first value, say 5, and our second value we're going to pass in just any number, maybe 10. But remember, we didn't, in the actual code, we didn't actually pass in the second argument. We just passed in the first argument, and we're using the default second argument. Default second argument is 1, so this should give us 6, and there you go. Okay, the result is actually 6, not 15. Okay, so just make sure that the rightmost parameters have to have default values. You can't have, they don't have to have default values, but only the rightmost parameters can have default values. Okay, so you can't have something like this, right? So now this can cause issues. Okay, so the rightmost, you can do this. Okay, so this is possible. Okay, because it is the rightmost parameter. So only the rightmost parameters can have a default value. And to give you another example, you can also do something like this. So say we had 3 parameters. So when I say the rightmost, it doesn't have to be the last rightmost. You know, it could be something like this. Okay, so basically you can't have any gaps or something like this. You know, this is incorrect, okay? Because again, the rightmost, the parameters with the default values have to be at the right, toward the right. So this is okay. Okay? That is okay. This is not okay. Okay, this is not okay. Okay, so hopefully that makes sense. So another concept I want to go over is inline functions. So inline functions, let's set this back. So there's nothing, you know, anything different you have to do besides one statement that you put before the function declaration that declares it as an inline function. Okay, I'm sorry, inline. Okay, so now this becomes an inline function. So what is an inline function? So when you don't have inline, what happens is the compiler will first kind of create the function, make the function available at any time, right? So you're kind of creating the function once, and it's accessible, you know, anywhere within your program. However, when you make the function an inline function, okay, it's going to create a copy of this function implementation at every point that you use it. Okay, so say I use it again, you know, somewhere later on. I said result 2 equals, you know, somewhere somewhere else I actually used, say num1 equals now 3 and int result 2. Okay, so say I did, let's give this a default value. Okay, so now I'm using it 2 times. So before we have one kind of declaration, one definition of the function it's in one place, and we're consistently kind of every time we call this function, we're making a function call. We go to that function, we do what it actually implements, and then we go back and back to, you know, where we left off. So when we do something as inline, so when we declare a function as inline, we're actually going to create a copy of that function at each location that it's called. So here we're actually going to create a copy of that function's definition, right, implementation at this point in the code. And we're going to create another copy at this point, right, using these parameters. So the inline function is going to consume more memory, right, because we're creating a copy of that function at each location that the function's used, but it's going to be faster, okay, because we're not actually making a function call, sending the parameters, you know, waiting for the returning the result. You know, it's actually, instead, when it's an inline function, it's making a copy of the function's implementation here, and so you have more copies, but it will be faster because you don't have to actually make the function call, it's immediately executing it. Okay, so the compiler knows how to handle an inline function versus a regular function, a function that's not inline. Okay, so that's how it actually makes the difference in how it compiles the function. Okay, so that's the idea of inline functions. Okay, so another concept I want to go over very quickly is passing by reference versus passing by value. Okay, so you should have read about this in chapter 6 as well. So the idea of passing by value is when you have a function here, you see when you pass in a value, you're actually passing in a copy of that value. Okay, when you're passing by reference, you're actually passing in the address of that variable, okay, of that value. So you're actually modifying the variable that's being passed in, and this is designated by this n%. So when you're passing by reference, it's designated by this n%. Okay, so when you call this function square root by value, you're passing in a copy of the value of that variable. Okay, so you're not going to modify the actual variable, you're just passing in a copy. And here you're actually passing in, you're going to be modifying the variable you're passing in. So you have to be careful when you're passing by reference. Be careful, because you are going to, if you are modifying this variable within the function, you're going to be modifying it in the same scope where this function was called. Okay, so let's just show an example. So let's look at how these functions are defined. Okay, so down here, what's happening now is we're reassigning the value passed in to the square root of itself and returning that value. Same thing when we pass by reference, we're doing the same thing. But just note, remember, when we're doing it by passing by value, we're actually passing in a copy of this value and doing the computation and then returning this copy. So we're not actually modifying the variable that's passed in. Now, it's different when we're passing by reference. We're passing in the address of the variable. We're passing the actual variable. So if we modify that variable within the function, we're modifying that actual variable. Okay, we're modifying the value at that memory location of that variable. Okay, so when we reassign x to the square root of x, we're changing that variable that was passed in to now the square root of x, the square root of itself. Okay, so you can see here what we're doing is we're asking the user to enter in two different numbers, 1 and 2, and we're just calling the square root function. Okay, we're calling the square root by value num1, and we're calling square root by reference num2. Okay, and then we're actually going to just print out what num1 is. So here we're passing in a copy of num1. So the num1 in this main function should not change. Whatever the user enters in, it should output that same number here, because we're passing in a copy of it when we're actually evaluating it and computing the square root. Even though we're reassigning it within the function, we're reassigning the copy of that value. Okay, so it's different when we're passing by reference, because now we're actually passing in num2 and we're going to be modifying num2, right? Because we're passing by reference. So when it passes in num2, because we have this ampersand, we're passing by reference, and it's going to actually modify num2. Num2 is now going to be equal to the square root of num2. Okay, so when we actually do this, execute this statement here, we're modifying num2, right? We're modifying that reference, that address. So when we actually print out num2, it's no longer going to be what the user entered. It's now going to be the square root of num2. We didn't even have to reassign it. We didn't have to do num2 equals, right? We're just calling the function. We're not assigning it to anything. But because we're passing by reference, we're actually modifying the variable passed in, the value of the variable passed in. Okay, so let's run this and demonstrate it. Okay, so here you see we're going to enter the first num. Maybe we'll say square root of 25. Okay, so remember that the first number we're passing by value, so it shouldn't change, right? The results shouldn't change. Now num2 we're passing by reference. Let's pass 36. So there you go. You see for num1 we passed a copy, right, of num1, and we modified it, returned it, but we didn't reassign it to anything. So it evaluated the square root, but nothing happened, right? We didn't reassign it because we passed by value. For num2, we actually passed by reference. So even though we did not reassign it to anything, we're passing by reference, so we're actually modifying this variable, the value of this variable, and it becomes 6. So, right? So it goes from 36 to 6 when it actually executes that function. Okay, so that's the idea of passing by reference versus passing by value. Okay, so that's an important concept to remember, understand. I highly recommend that you look at additional resources online. If you need to watch additional YouTube videos, do that. but it's a very important concept to understand. So another concept I wanted to go over is called templates, so function templates. So function templates are good when you want to write sort of a generic, very generalized function. Basically, the function doesn't have a specified type, parameter type, or return type, and allows for any type of parameters and return types to be passed in, as long as they're consistent. So here's an example. So we have a template, a function template called maximum. So this is the syntax for actually defining a function template. You specify template, the type name, so we called it my type, and then here's our function declaration using this template, right? This template name. So it's a generic type, right? It's a template. So we call it my type. So this can be anything, an int, string, double. We're not actually specifying what it has to be. It can be anything, and it just has to be consistent. So this same type is going to be the parameter, the first parameter, the second parameter, and the third parameter. So this function is going to take in 3 parameters of a specific type, any type, and it's going to compute the maximum of these 3 values, regardless of the type, and then it's going to return the max value, and that's going to be the type, same type as the parameters. So here, down here, we actually define it. So we can actually remove this. Okay, so down here we actually define our maximum function template. So here you can see that we actually inside, remember or not, we didn't actually specify a type, so it's called my type. This is our template, and this is the max. This is the variable name, max val. We're initializing it to the x1, right? The first parameter passed in. And then we're checking to see, so this is just basically determining which of these 3 parameters is the max value, regardless of the type. Okay, so we're checking to see first, is x2 bigger than the max val? So first we initialize the max val to be the first argument passed in. If x2, the second parameter, is greater than the first, then it becomes the max val, right? We're assigning x2 to the max val. And then we check, is x3 greater than max val? So now check, is the third parameter greater than max val? So max val at this point could be x2 or x1, depending on which was greater. And then it checks to see if the third is greater than that current max val. And then it returns the max val. Okay, so you're still defining the function the same way. It's just the type that is different, right? The type is a template. It's a generic type. Okay, so that's also important. So when you actually execute or define and implement your function, you have to be aware that if you want it to work with any type, you have to implement it in a way that works with any type. Okay, so in this case, we can pass in an int, double, even a string, right? You can compare strings with the greater than sign, so you can pass in a string as well. So here we actually use this maximum function. So we're going to pass in integers, right? So now we actually define the type, and we're going to read in 3 different integers from the user, and we're going to pass in these integers, right? So we're going to pass in these integers, and we're going to return an integer, max. Okay, and then we're going to print that max value out. So let's see that run. Okay, so here's our console. We're going to type maybe 10, 15, and 2. And there you go, the max value is 15. Okay, it works as expected using the function template. So what if we change this to a double? So there you go. This is one of the advantages of using a template, right? Look how easy it was to change our code to work now with a double type, right? So before we were working with ints, we just change it to a double and it'll still work. We don't have to modify anything, right? The function template is defined in a way where any type can be passed in. Okay, so all we had to do is change this from int to a double. We didn't have to change anything else, right? We didn't have to do any sort of conversion from a double to an int or any of that. We just declared it now as a double and it should still work. So let's run it now. Okay, so we're going to pass in 10.5, 2.5, 15.3. And there you go, 15.3 is the max. So it works with doubles as well. Okay, so now let's try strings.
Now we're going to pass in, actually pass in strings as arguments into this function. Okay, so notice it still will work, right? All we have to do is change this to a string, and now we didn't have to change anything else because this is a function template that accepts any type. So now we run this. Okay, so now remember, when you compare strings, you're comparing it sort of alphabetically, right? Alphabetical order. So A is smaller than a B, Z is greater than any other letter. It also looks at capital letters versus lowercase letters. So let's just do 3 different words. Let's do maybe apple, zebra, and cow. So this should be, zebra should be the max because Z is greater than A and C, right? It's higher value in the alphabet. So it's higher up in the alphabet. So zebra should be our max value. And there you go, you get zebra. So notice this program still worked regardless of the types that we passed in to the maximum function, because again, we're using a function template. So this is the power of function templates, right? It sort of generalizes your code, makes it easy to modify your code if you need to change the types of a value. It also just makes it simpler in that you don't have to implement multiple functions, right? You just implement one function and make the type generic, and it can work with any type. So this is a very powerful tool. You should take advantage of when you can. Okay, so the next thing I wanted to go over is function overloading. Okay, so function overloading is the idea of calling the same function name, creating a function with the same name but different signatures, different parameters, and or return types. Okay, so looking back at this example, right now where it's only expecting a double, right? So what if I wanted to allow integers? So what we could do is do something like this: int square root by value int. Okay, so let's disregard the square root by reference. Let's just look at these two functions. Right, so notice that they're both the exact same name, right? The only difference is the return types and the parameters, so their signature is different. Okay, so this is the key idea between function overloading. It's using the same name of the function, but different either parameter types, number of parameters, right? You could maybe do something like this, and or different return types. Okay, so the main thing that has to be different though is the parameters, right? The parameters have to be different. So it's either the type that's different or the number of parameters that are different. The return type can also be different, but you can't have the same type and number of parameters. You can't have the same types and number of parameters in different return types, right? This is not how you can do function overloading. You have to have either a different number of parameter types, right, or a different parameter type. So different number of parameters or different parameter types. So another option would be something like this. Okay, so this allows you to have two different functions. Okay, two different functions, the same name, but they're implemented differently. They allow you to pass in two different types of variables, of values. Okay, and again, you could have done something like this, or maybe this one of the functions, again the same name, so this function is overloaded, right, but different number of parameter types. Okay, so that's the idea with function overloading. You can have the same function name, but either different parameter types or different number of parameters, or both. Okay, and they're also going to have different return types, but they can't have the exact same type and number of parameters and different return types. Okay, so that's the idea of function overloading. So I highly recommend that you read through that in the book, as that's extremely important to understand, and we'll be using that later on in this class as well. So the last concept I want to go over is recursion, right? So recursion is extremely important. It's based on the idea of a function calling itself. Okay, so we have an example here from the book. It's an exercise 7.28. This is from the end of chapter 7, but it is a recursion exercise. Okay, so the idea here is you want to test if a word passed in is a palindrome, right? A palindrome is if you reverse the letters of the word, it says the same word, right? So like level here, if you reverse the letters, you still get level, right? It's the same word. That's what a palindrome is. So the idea here is you pass in a string and it returns a Boolean, right? True or false, whether or not it's a palindrome. Okay, true if it is, false if it's not. Size t is a parameter. It's sort of like an integer. You can think of it as an int. Okay, size t. This type is typically used with arrays, so it's used to index arrays, and it's sort of optimized for that. So you could use an int, but size t is used, and you'll learn about this in chapter 7. So again, it's just a type that's used for indexing arrays. Okay, so the idea here is that the string is an array of characters. Okay, so that's the array we're referring to. Okay, so we're going to have this recursive function, test palindrome. It's defined down here. This main function just asks the user to enter in a sentence, and then it calls the test palindrome function, and if it is a palindrome, it returns true and prints that it is a palindrome. If it's false, then it prints it is not a palindrome. Okay, so that's the main function. So let's actually look at the recursive function. So this is seen here. So again, I highly recommend that before you kind of look through all this, attempt it on your own. See if you can write a recursive function that does this, that returns true if the string is a palindrome and false without. You're kind of given a hint here. You're passing in a string and two integers. You can think of these as indexes or integers, right? Size t types, and you should be able to implement this recursive function on your own. So try that before I'm continuing with the video. Okay, so this is the result. So after you tried it, you can see here, see if you did it correctly. So here's the recursive function. So again, you pass in the string, right, the palindrome that you're testing, and then size t left, so the left index and the right index. So basically you have this if statement, if else statement. The if, you're checking these two statements here are the base cases, right? These are actually going to return a value, true or false, right? So you also have this recursive statement. So you have your base statements, which kind of stops the function from calling itself, because it's going to, if this is true or this is true, it's going to return true or false and not return the test palindrome function, right? It's not going to call itself. Okay, so this is the idea that it's calling itself. And then you have your recursive case. Okay, your recursive case is the case where it returns the function call. Okay, so you can think of it as each time you call this function, it's sort of stacking a record of that function with its own values on a stack. Okay, and then you have to kind of get back to the original. So what's happening here is you pass in the palindrome. You pass in, remember, you're passing in 0 and the length. So 0 is the first index of the string, and put.length -1 is the last index of the string. Okay, so that's the first thing you're going to pass in. You're going to pass in 0 plus 1, which is the next, right, is the next value. So if it's, and then right -1. If it's right -1 is the next one in from the right. Okay, so remember, it's going to check left is right. So basically it's checking if the left index is equal to the right index. That means you're done, right? Or the left is greater than the right. That means you're done. You've checked all different letters on each side. Okay, so you can return true if you can get to that point. Okay, if you get to a point where the left character, right, palindrome left, these square brackets are accessing a character in the string. If the left character is not equal to the right character at any point, you return false, and the entire function will be false. Okay, so at any point it returns false, then it's going to go back up the stack and continuously return false for all the function calls in this recursive function. Okay, so if it doesn't, if they are equal, then it's going to continuously call this function until left is right. Okay, so it's only going to continuously call this if the left and right are characters are equal. So if you're going to check to see if L and L are equal, yes, it's going to go okay. Is E and E equal? Yes. Okay, we're at V now. At V, the left index is equal to the right index, as you can see here, so we return true. Left is right. Okay, So that's the idea with recursive functions. I highly recommend that you kind of think through this, make sense out of it. Recursion is very important. If you have any questions, please reach out. Thanks.